Hello, welcome to Mr. CFD. In this video, analysis of the results of this CFD product, Cylindrical Heat Source in ANSYS Fluent software is presented. Let's start with the pressure contour. The pressure distribution offers additional insights into the flow behavior. The highest pressure is observed at the inlet, which is expected due to the incoming flow. There is a gradual pressure decrease along the length of the cylinder, indicated by the transition from red to yellow to green. The lowest pressure is seen at the outlet, consistent with typical flow behavior in a constricting channel. The pressure gradient is relatively uniform along the length, suggesting a steady acceleration of the flow. Now let's see how velocity is distributed along the domain. The inlet shows very low velocities consistent with the reported inlet velocity. There is a dramatic increase in velocity towards the outlet, with the highest velocities observed at the exit. This velocity increase is primarily due to the reduction in cross-sectional area. The velocity gradient is most pronounced near the walls, indicating the development of a boundary layer. About the flow acceleration, we can say the significant increase in velocity from inlet to outlet is due to the conservation of mass in a constricting channel. This acceleration might enhance heat transfer by increasing convection, but it also reduces the residence time of air in the heated zone. Let's discuss temperature changing along the domain. This graph provides a clear visualization of the temperature change along the axial direction. As you see, there is a sharp temperature rise from about 300 Kelvin to over 1600 in a very short distance. After this initial rapid increase, the temperature continues to rise more gradually, approaching 1800 Kelvin at the outlet. This graph confirms that the most significant heating occurs near the inlet, with diminishing returns as the air moves toward the outlet. As we showed you in the temperature graph, the heat transfer is most effective in the initial region. This could be due to the higher temperature difference between the air and the heat source in this area. But about heat source effectiveness, we can say the constant heat source of approximately 259,000 watts per cubic meters appears to be very effective, raising the air temperature by nearly 1460 Kelvin. However, the diminishing temperature increase rate suggests that extending the cylinder length might not significantly increase the outlet temperature. Hope this video is helpful for you. To benefit from Mr. CFD services including simulation, consultation, and training, visit our website www.mrcfd.com or contact us via info@mrcfd.com.